Good evening, everyone. Thank you very much for choosing to spend your time with me, for being my companions tonight. I think I was one of the first members of staff who gave a lecture, actually, in computational mathematics when the room was refurbished. And I can tell you, today I have a much better turnout than I used to have for my lectures. This being a mathematical lecture, I wanted to include some quizzes as well, but I decided to skip them. Yes, and let's start the journey. So this is the outline of the talk. So I'll start with a brief journey, and then what is mathematics? I think we all have some idea or some perception of what mathematics is, but we'll see what other people say about mathematics. Then some maths metaphors. To me, mathematics is the language of God, because I think it's one of the greatest gifts we have. And with mathematics, we can see some things which cannot be expressed by poetry and even by theology. So mathematics is not able to only state things, but is able to prove them as well. So this is why we are going to discuss about some of my favorite maths metaphors, which include infinity, and then fractals. Then I will show you some maths research, which is pure and applied, and then some details about math support for all. In my description of the talk, I mentioned like innovation in pedagogy and so on. I like to mention that I'm not like an innovator who pursued innovation for the sake of being an innovator, of trying to do something new. But I was in the classroom. I was thrown in front of the students. I had 150 students in my first lecture, and I had to find a way to interact with them. Most of the students did not want to be there. Hated mathematics. I was teaching computational mathematics to the students who hated mathematics. I had many students who were mature students. I had many students who were with various learning disabilities, and you had to find a way to teach them all. And actually, this led to all these innovations. So it was just driven by the need to help the students. And during my time as a lecturer, I learned this golden rule of teaching maths. So you must tell the truth, nothing but the truth, but not the whole truth. So that's why I will skip many of the proofs. Also, I'm very delighted to see that I have some former students in the room. They do not know that they appear on the slides. So this is a quick profile summary. I did the PhD in applied mathematics in University of Nottingham. Then I completed the PhD in pure mathematics. I will tell you a little bit about how that happened. I've been Erasmus and Turing scheme coordinator. So I will tell you more about what I found when I arrived in Derby. Then I was very keen on developing international collaborations. I think this is something that the university was really lacking. And then even when we were having some collaborations internationally, the students, our own students, did not know about those, and they could not benefit of the opportunity. And then in the recent times, I became program lead and program leader and the lead of these partnerships in China. I show you that map. So this is like a pretty up-to-date map of the places I visited. I would like to mention that I never visited a place without giving at least one talk. Sometimes 7 talks. And I think one reason why people kept inviting me, was that I tried to never say no. But this meant that I had some amazing opportunities. Now, before we really launch ourselves into the journey, I have an invitation for you. So if you see any small item that could help your students, please take that and implement it. And that will make me very happy. I've been involved with the University of Derby. So I think my journey is also the University of Derby, from a place which was mostly teaching focused, local, along this amazing journey as well. Because during my time here, we expanded significantly Erasmus opportunities for teachers and students. Then we joined the world university rankings in the top 1,000 universities. So when I joined Derby was not even in the top 100 universities in the UK. For me, it was amazing when, I think through some things where I played a little part as well. The university joined the top 1,000 and then the top 800. And then we've been like 500 to 600. So I think we are really going up and up. Then TEF Gold, Teaching Excellence Framework. Again, the university provided excellent teaching experience to the students throughout, but then to get this rating as well nationally, only 27 in the previous TEF. I know that 27 universities out of 150, I don't know exactly how many, but I know that only 27 had gold. So I was very happy to be part of this journey. And now the Turing scheme. So my journey started in Zărnești. Have you ever heard of Zărnești? Yeah, this is a small town in the middle of nowhere, end of train line, near the mountains, 5 kilometers away from Dracula's castle. Maybe this puts it a little bit on the map. Now we have an airport nearby as well. And I had a happy childhood. I was mostly in the trees. My cousins were making poems about us just being in the tree. Then when I was dressed in orange, we were reciting some communist poems. So that was still communist Romania. And then this is my first school day with my lovely mom, who provided and really lived for us. I met infinity through my mom. We were playing numbers game in nursery, and we were playing who could say the biggest number, and we were saying 10, 100, 1,000, 1 million, 1 billion, 1 trillion, and then I went to my mom and asked her, "What's the biggest number?" And my mom said, "An infinity of infinites. That does not exist as a number. It's not a number." But I was winning all these arguments. And that was the first time that made me think. Then I went to primary school. My first grade was 90%. I was very proud, right? I was telling my mates, look, I've got 90%. My mom was not impressed. I got some feedback from her. And then I learned not to mess up with mom. And I knew that mom expects me 100% because she was giving her 100%. So I was very privileged from this. I had an experience in the classroom with, this is my primary school teacher, Aurel Rusu. And he stretched me during the class. Mama was asking me to do math, but I did not really like it. And this teacher asked me to go to the front of the class and write a proof on the board. All my mates failed. And I thought I would be safe as well. But he said, no, if you don't prove, I fail you. And then something activated and I was able to write the proof completely. I said, oh, so actually I can do it. And then I started in the secondary school. We have a very intensive maths competition program in Romania. It's quite heavy. Students are drilled. You have local competition, county competition, national level competition. But I was in the middle of nowhere. I did not have like special training like you have like in the camps for maths, Olympiads, and so on. I was still from the small school in Zărnești, and then I met this lovely teacher, Lucia Lepădatu, and with my teacher, we started to practice a little bit for these competitions. Then, when I was in year 6, I came 5th in the county competition. And then I promised my teacher, next year we'll go to national level. And she said, yes, never. No one from our school ever went that far, so don't worry. Then next year, I had the perfect score in the competition at county level, and I had to qualify to national level. But because I was from the countryside, I was put aside. They deducted 2 points for nothing. This teacher went to appeal to county level with the director of the school, and we were allowed to have a competition only between the guys from the countryside. And then yes, and I was fortunate because I got ill that period for a month, and I could practice properly, and I solved all the books I could find, and I came on top. And then I went to the national level, and I was the best student in the whole county for all age levels. So I had the prize. But then next year I wanted to have the top prize in the country, and I was praying. I did not go to the church at that time. I did not know much about church, and my prayer was, God, I want wisdom. I want to be first in the country in maths. That was my prayer. Simple prayer. And then through snow, through rain, and so on Sunday, I was going to my teacher every Sunday, and I was solving problems 6 hours, 8 hours a day after class. And then Sundays, I was going to my teacher to discuss Actually, it was like the brainstorming in two. And I'll cut all these stories short, but what happened was that against all adversity, I went to the national competition. I could not sleep for 2 nights because of trains, because of stress and so on. But when I went to the train, the night before, I had a meeting with the teacher, and I gave her 2 problems that I could not solve. In the morning, this teacher came, did not sleep, and came with the solutions. In my mind, I figured them out because I was very focused, and during the sleep, I could solve that. But my teacher, the image of this teacher stays with me. And this teacher is in this room today. So it's like the support. Yes. Then I went to high school in the best high school in the county, and now I wanted to be the first in the world. And I am very happy I did not. I lost focus. I started to spread out, like Stefan mentioned. So I still now I realized that I could do choir. I was in the rugby team. I was in the basketball team, and so on. So I think I was doing too many things. But then salvation came from somewhere else. Salvation came from. So I had a teacher in the class, and this teacher showed us how you can do mathematics with humor. So even when your students are stressed, if you tell like the right joke at the right time, you can reduce the tension in the classroom. And then I was very fortunate because aged 15, I met a teacher who was of Hungarian origin. This guy met Erdős. So Erdős is a famous mathematician who wrote 1,500 papers. He was traveling around the world, meeting mathematicians. Everyone has an Erdős number. So if you publish a paper with Erdős, you have Erdős number 1. If you publish a paper with one of his co-authors, you have Erdős number 2. And this person knew Erdős, worked with Erdős, and he was a school teacher. And then he saw me, but we met at a camp, and he said, "Young man, you have some talent for mathematics, but do you know that in mathematics there are problems that cannot be solved in 3 hours, in the 3 hours you have in a competition?" And this really made me think, and this changed my perspective on mathematics. From that moment onwards, I started to solve problems, but thinking that, what if I change this condition? Can I generalize this result? So I was losing focus on the competitions, but then I was starting to think about research. Then I nearly gave up maths. But then I had the rebound when I was 18. I won Kangaroo de Mathématiques. This was in Paris. I also met Father Théophile. I think he brought me like into the church. He told me, "Look, you have talent, but you cannot leave mathematics. So you cannot leave mathematics. From now on, your life schedule is oxygen, glycogen, sleep, maths, and then don't miss liturgy. And don't be a rascal." That's his advice. But he was very sweetheart. Yes. And then like meeting in the classroom of Professor Bence. So this is Professor Mihai Bence, who is here today as well. So I think Professor Bence was inspiring students because he was playing the piano, he was playing the organ in the Black Church, in the famous church in Brașov. He was writing poems. He was with cultural activities. He launched many math competitions. He authored more than 15,000 proposed problems and more than 6,000 open questions. And we are still working with Darby students on open questions. I'll tell you more about it. But in the same room, when we had tuition, we had Radu Butum and Iunis Ștef. Radu decided to follow diplomacy, and he's now the current head of the liaison office in Erbil, in Iraq. And Radu is also here. And by the way, he will have a lecture. He will have a lecture tomorrow, showing how you can solve diplomatic issues through numbers and data science. So I hope that will be interesting. And then also Iunis Ștef. He was like the genius in our high school. He was going to national competition in chemistry, physics, mathematics, and then he studied mathematics. And I insist on these two guys because you will see in the next slide, I don't want this presentation to be like my Instagram, where everything is perfect, because my life is not simple, is not linear, and it has its ups and downs. And I had my very low points, and then I had friends who raised me up. So if you raise your friends up, you are doing a good job. So when I felt down, I had a failed year in university, and I'm happy about that. My mom was not happy, but I'm happy. And then these are the guys who welcomed me to their city. So I changed cities. They hosted me for a while until I found like my groove to do mathematics. So I was for a year in Bucharest in the Polytechnic Institute. We had 35 hours of face-to-face activities a week. It was quite brutal. Our classes Saturday, and then you had to do the labs overnight. Many of the survivors got very far. So they are leading companies. We have one such survivor in the room. So this is Professor Sorin Olaru. So he is the head of the Intelligent Systems Lab in Paris-Saclay. So he survived Polytechnic Institute. He did PhD as well. But I failed my first year. And actually, my salvation came through research. Because while preparing for an exam, I found a nice problem. And then instead of preparing for the exam, I started to solve this problem. And I thought, this is a way to arrange the numbers from 2 dimensions on a single line through an exact formula. So with 2 variables. I will not explain the proof and so on. But then my question was, how can I do this in 3 dimensions? And then 4 dimensions and so on. And that was my first published paper. I had 100% grade equivalent for that exam, but that was my last exam in that university. And then I went to Cluj-Napoca. In Cluj-Napoca, I did BSc, MSc. It was totally different atmosphere with mathematics. I started to publish papers solving open questions from Octagon, also solving my own interests. I started to be interested in inequalities. So inequalities are actually the dominating relation in mathematics and life. So this is an inequality. So you have x, y, z are 3 positive numbers. And whatever those numbers are, this expression is greater or equal than 3/2. Equality is actually a particular case of inequality. So you have 2 numbers are equal if one of them is greater or equal than the other, and the other is greater or equal than the first one. So equality is actually an accident. But then I started to publish. I had great guidance from 2 teachers. One of them unfortunately passed away. So Gabriela and Mirela Cor. So they provided me lots of guidance, tutoring, and so on. And then I also met the person who really solved the equation for my life. Because during faculty, I was focused on mathematics, but I was also trying to solve a conflict. Because I was going to church, I was faithful, but I was wondering, am I not wasting my time doing mathematics? I was going to the library for 6 hours. I was reading theology books 3 hours. I was reading math books for the remaining 3 hours. And there was a conflict in me. And then through this is a metropolitan, like a cardinal in the Orthodox Church. And he was an engineer. Then he studied theology, 2 PhDs in Jerusalem. And he told me, no, you are not doing theology now. Your way is mathematics. And he told me, an astronomer who discovers a new star brings a liturgy to God. This solved the equation for my life, because I realized that whatever I do, so working my talents, this is how I can fulfill, I have a fulfilling life. Then I came in the UK to do PhD. I did my PhD in the University of Nottingham, a great applied mathematics project, stochastic receptor ligand binding under force. So this is about how the cells, this is the process which expresses how cells adhere to each other. This appears in many processes like morphogenic movements, metastasis, tissue formation, wound healing. I had to build a model. So we were considering that 2 cells are modeled as 2 plates linked by some bonds. These bonds, everything was under force and in a fluid. I did not like this project too much. Everything was nonlinear. I like to do formulae. I wrote a formula for an n-dimensional integral, but I could not solve it numerically. So what I had to do, I had to learn MATLAB, I had to learn stochastic simulations, Markov processes, discrete time space, discrete state space, continuous time, and so on. So I could do only simulations. But I ended up getting my PhD, also a daughter in the process, Stephanie. But I think maybe one of the biggest achievements I realized about my PhD is that I could really branch to the UK academic tradition, and this is what I'm trying now to promote around the world, because I had 3 PhD advisors. This is you can click on this thing, and this is the mathematics genealogy project. So you can see who's the supervisor of your supervisor was, and then who's a supervisor, and so on. And then you can trace your academic ancestry. And then my I had 3 supervisors. One was expert in fluid mechanics, another one expert in statistics, another one expert in pharmacology. And then through Professor Oliver Jensen, who was my main advisor, and the best students in the AMTP in Cambridge, I was linked to many Nobel Prize laureates. So J.J. Thomson, James Maxwell, then certain Isaac Newton, then Galileo Galilei. Tartaglia, he's the one who solved the cubic equations for the first time. Then Desiderius Erasmus, then Isidore of Kiev, and then Gregory Palamas. Gregory Palamas is one of the greatest theologians ever. So I was quite happy. But then in 2000, I was jobless after I finished my PhD. Yes, and then I also wanted to ask you, you can start now, if you have some pen and paper, you can write a probability of the events happening for each slide, and then you can multiply these probabilities to see what you get in the end. So in 2012, in 2011, actually, right in December, after I was graduating, I get a phone call from a friend in the church. Like at that time, our priest was applying for jobs. My friend was applying for jobs. No one had a job. And then this friend of mine calls me. He says, "Look, Dumitrash, I found your job. This is your job. This is lecturer at Derby University. I tell you, this is your job." Then I called the priest. I said, "Father Dan, what should I do? Tomorrow you call them." Then I had a meeting with the people in the University of Derby. I had a meeting with the head of school, with the head of subject, with the principal tutor of the university, Stuart Berry. I think many colleagues know Stuart. He was here for 43 years. And I applied. I got the job. And I became a part. I had a very interesting interview. They asked me how much did you earn in the previous job, and I was so nervous, and I wanted to say 24K per annum, and what I said was 24K per week. and then Peter Larcom was took a notebook, and he said, "Which company did you work for?" Then the head of school said, "I'm afraid we cannot afford to pay you that much, but maybe we can sort something out." And then I made 2 promises, which I'm trying to keep. I told them that, look, I'm very happy to join. I'm not here for the paycheck, and I'm here to make a difference. What I would like to say now, after becoming professor, is that I do not see this as a prize, as an award for various merits, but as an investment. Right. So I'm the investment of my parents. I'm the investment of my teachers. And I'm here to help everyone raise their game. Now, the first meeting in 2012, we had the first meeting with some academic team, and the topic was, what is research? We were trying to define. We did not have ChatGPT to tell us. So we were trying to define. Let's define what is research. Is it primary research? Second, then we had the statement, yes, we are all happy with this definition. The university had research, but it was in pockets. Research was more like a curiosity. So there are some people doing research, and I remember, oh, that person is doing research. It was something interesting, but it was not very common. Then in 2013, again, I was here. So I'm very happy to be here as a witness to tell you, maybe to realize together the huge improvement of the university in a very short time span. Because we don't have like 800 years of history, we only have 33, right? In 2013, the vice chancellor of that time, Professor John Coyne, mentioned research for the first time in a vice chancellor's briefing. Like, staff are encouraged to do research. It's good. It's actually, there is value in doing research. I tell you that we went outside the room and we started to jump around the people in computing because we were doing research. Then 2015, I have to tell you, that's why I have the picture with Kath on this slide, because that, for me, it was love at first VC briefing. So why? Because so Kath gave the message and so on, but then a colleague asked the question. He said, "Look, what about the people who are not doing research?" And Kath's response was, "Sorry, if you are not doing research, you are not an academic." And for us, for the people who were trying to get some recognition for the research we are doing, that was a massive boost. And now I also want, so there are colleagues who are focused on teaching. So I think that's brilliant. But I think even in that case, you can still do some research because you get lots of data from your students. You can do reflective research, right? You can reflect on your practice, what went right, what went wrong. You can get research out of that. So I'll show you how I've done this also with my students. And then 2020, we had REF, and I was very happy to contribute to the REF submission of UA 11 because it was REF, how is that, transfer season. We lost two professors through transfer, one professor through illness and so on. So we did not have too many people to pick up the submission. We were sitting on a gold mine because I was able to witness. I stayed here for the whole period. And I knew that we had papers in Nature. I knew that we had papers in Frontiers of Computer Science, brilliant papers. But those were, we did not have like a clear understanding of the value. And then I stayed like for a month with the security guys. They were asking me, when you go home? I said, when you go home. So that was like midnight. But then we were able to get like all the data in a good shape for the ref submission for UA 11. We selected our 43 outputs and we had 279 average out of 4. The second highest in the university, 2%, so 0.002. The first one was 281. Right, so I think now the university started to submit big bids. I think we recruit brilliant stuff, and I'm sure the next ref will be even better. So I was very happy to be part of this journey. But this also had an impact because we did not have a submission in mathematics. So this means that I had to adapt my research so that I can be part of this submission as well. I started as a pure mathematician. Then, because I was trying to help my students, I started to get interest in math anxiety. This is the fear of mathematics, frica de matematica. This is frica de matematica. And then I realized that we had world-leading expertise in our university. So we had David Sheffield, we had Tom Hunt, who were leading experts. So I could identify through this interest some other pockets of excellence in the university. So this is why my research is fundamental research, applied research, and then pedagogical research. Now, to help my students, I started with this class, computational mathematics. So I started by preparing the best resources I could. So I produced a textbook. I started to use recordings as soon as they became available through Panopto. I started to use math jokes inspired by my teacher in high school. But then I started to focus on e-assessment as well to help all the to help the students practice. And then numeracy skills training and so on. This allowed me to present at many conferences. I think we had very good results in mathematics in National Student Survey. I started to do Erasmus visits, and also I started to bring companies to the university so that we get the latest technology in the classroom. This can be dangerous because if you draw the attention of senior people, then you'll get jobs as well. So I had a big job from Warren, who was Professor Warren Manning, who was at that time the dean of our college, and he said, "You will do the TEF submission for maths. You are the person to do it. Come, I'll explain what this is about." And I think yes, we did well. And then in 2020, I became senior fellow of the Higher Education Academy, and again, I think this really crystallized my key direction. So first was internationalization in higher education. So this is university students and staff traveling abroad, but also internationalization at home. So through Erasmus, we were able to bring some of the leading experts in Derby. And then also technology in mathematical education. And I've seen that, for example, with e-assessment, this is how I could deal with students, with 150 students in my classroom. And then by deploying formative assessment, the students could lower their anxiety because they could practice the tests and fail as part of, and this became part of the learning process. Working in partnership with the students, I think this was a big lesson for me. So I started to listen to the students' voice. I started to engage. My first feedback was not great. I tell you, I was not in this room, but after my first lectures, I said, look, the students were very quiet. I said, maybe something is not going right. And I said, look, I will expose myself. I will tell the students, look, I really care about your feedback. Tell me exactly what you think. I was not ready to hear that. They said I had feedback. Ovidiu moves and speaks like a potato. That was... But then after I took action and after I started to learn from this, because student satisfaction with feedback in computing modules was often in 40%, 50%. So I thought, look, I should engage with the students to see early on what do they want. I should tell them a little bit about feedback. So what is feedback? And then I had the feedback at the end of the year was, as a result of our feedback, Ovidiu became a much better lecturer. So that's why I was able to tell you the one before. Right. And this is during COVID. COVID was a very interesting period, I think, for all of us. So during the lecture, suddenly someone pops a link into the chat box, and then all students could get this. And this was a student, Federico. You'll see him in the following slides. So this was his reflection. He was in CELT, so in the Center of Excellence in Learning and Teaching, and this was his reflection of how effective the tools he saw in his classroom were on his learning. But then, inspired by this, I said, "Oh, Federico, okay, good. Now you go with Erasmus. We have a conference in Portugal. You are going to reflect more on this thing. Work with the students. What went well? What did not go well? And then you are going to present your findings at the conference." Yeah, so this is Federico. He was student ambassador, but you'll see him more. Then, something that had direct impact on the students at Derby was the visit of my teacher from Cluj-Napoca. This was a genius teacher who was working with Maple, with the company, to help them improve their algorithms. So he knew like Grosvenor basis, like lots of very advanced mathematics to improve the algorithm. But he came and he gave a lecture on how you can use MapleSoft to solve research, teaching, and all sorts of things. Then I contacted MapleSoft. I said, can we have some licenses? Can we do some trial with Maple? Then we started the pilot project. That went really well. Then we had site license. Then we had access to their books. We had a partnership. And then they started to have sessions for our students only. So we had like tailored sessions. Then I followed the same approach with digital ed. So this is they were the producers of Möbius. And then so some of these tools were deployed after we had a meeting in the college in 2018. We had high failure rate in maths heavy engineering modules. This was a problem, so pass rate was maybe 40%. And then we started I was invited because pass rates in my module were 85%, where I had the assessment and all these tools. And one measure adopted was deploying Möbius. We have a colleague, George Dixon, and then when he deployed that in 1 year, So pass rates went up significantly. Then I was invited to online seminars to discuss whether STEM can be taught online. It was COVID, so I said, now we have to. So anyway, so yes. And then this is a book I started to read in the night before my interview at Derby. And actually, this really changed my perspective on my value. I thought I would get the answers to the interview questions, but I got something more valuable. And that was that every employer is looking for the same skill. And this is problem solving skills. And then I realized, actually, I'm a mathematician. I'm a problem solver. So problem solving is about understanding the problem, making a plan, implementing the plan, revising, and so on. And like this is my creed for education. I think educating the mind without educating the heart is no education at all. So this is what Aristotle was saying. And I really think that I believe that education's purpose is to replace an empty mind with an open mind. Now, in order to develop a problem-solving culture at our university, from my first semester, I started to do maths competitions. Then quickly we realized that this is not really the way to go, like single, like individual competition. We started to have team competitions. This went really well. We had 14 editions. My colleague Nicolas Korpelainen started to lead on all these developments. And then in order to improve student satisfaction, we also joined the choir. And I think this really made the difference. Yes. And actually, the first time I met the vice chancellor was not through like booking a private meeting and so on, but I met Kat in these events. So she was always attending this choir, the university choir. We had Carol's concert, the graduation ceremony concert. And this is when I remember that first time when Kat approached me, she told me, "You are doing a good job. You are making a difference in your team." I thought, how would she know? Because I never, I never interacted. But she was aware of what we were doing. Then we started to organize maths events. So I heard that this was Colm Mulcahy. He was he was a mathemagician. He had a UK tour like Madonna, and he was going to like many, like Cambridge, Leeds, Birmingham, Manchester, and so on. And then I dropped him. I saw that he had a pause. He had a break in his schedule. I said, Colm, hello, professor, could you please come to visit Derby as well? I said, actually, I'm visiting a friend nearby. And then we organized an event in the big lecture theater with Mathemagic. And again, what is the impact? So I don't want to just provide like a list of things that I've done and you say, yes, good, you work very hard. But I want to show the impact these things had on our open days, because we started to do Mathemagic. Then we have students who are now leading the magicians activities like Mathemagic in Derby. So we have Tim Green, who is now working also in Gors. And like this thing really left a trace. Then careers events with the maths twist. So we had Ashley. So Ashley was senior operational research analyst at the Department for Work and Pensions. And he was joined by one of graduates. I realized that so during a placement visit, I had, so I went to Newcastle to visit the student. And on the way back, I met Professor Tom Ward, who joined us today as well. He's like my mentor for like mathematics in the UK. He was provost education, and he kindly showed me around in terms of facilities they had. And the one thing that stood out was the visit to the alumni office, and that had about 17 staff. When I came back to Derby, that was 2015-16, I asked my head of department, what alumni office do we have? Because we have like all these great stories. We want to keep in touch with the students. He told me that at that time we had someone, he remembered having someone part-time. Now I know that we have a team, and we are now working with colleagues in data science to help get the data on our alumni to really keep in touch with our students. And then we also organized in 2018 a public lecture with one of the greatest mathematicians alive. So this is Preda Mihailescu. Very interesting life story. He's also Romanian, but he's the one who solved Catalan's conjecture. That was an open problem in mathematics for 158 years. And then he's the one who solved this problem. And then he came to Derby to speak to our students. And his talk was called With Mathematics on the Road. So this is what inspired me to choose the title for my talk as well. But then we were using all these events as training opportunities for our maths ambassadors. One problem that we faced in Derby was that the maths team has always been small. At some point, it was only 2 persons. We were getting lots of invitations from local schools. Can you come to speak to our students? We want to have some activities. And we had to reject many of them. And I realized, yes, we should not reject all these things because we don't have too many staff, but we have lots of good students. And then we can train the students, we can deploy them to local schools. Then we realized that we had a fantastic widening access team, schools liaisons officers, and then through DANCOP, through Raising the Grade, we were able to deploy all these Derby students to local schools, to help teachers, to help with Raising the Grade. This was an event at Deferers, and this was with 500 students. And it was our Derby ambassadors, all with Maths at Derby t-shirts, helping them. Then staff experience with Erasmus+. Here I have some pictures with the colleagues in engineering. So we have Tim, we have Mark. So all this, we had in the morning, we had the research visit. In the afternoon, we were in the jury for the national engineering competition for students. Then we had the graduation ceremony. Mark was enjoying papanash. Papanash, this is a very traditional dessert. Then with Tom Hunt on maths anxiety, visits to Turkey, visits from Turkey. So why is this important? What we were doing this during this visit? So I remember that when we went to Turkey, so we met the vice chancellor. Then we went to schools, and we could see that in Turkey they were doing research not only on the student anxiety but also on the teacher anxiety. We could see the problems faced by the math teachers teaching refugees. And they were saying that we had an Afghan refugee child and he slapped one colleague and then waiting with the parents at the gate, right? And then we could exchange experience to see, look, life is complicated for those people and we can learn from their experience. And then this is the last Erasmus visit, unfortunately. So due to Brexit, we had to change plans. But I was very happy to take Stefan, to take Farid, to take Harry, to Alba Iulia, where we have great partners, and to Cluj-Napoca, where we also have great partners. And here I'd like to highlight Dr. Ioan Lucian Popa. So he's same age as me. We met when we were both young lecturers, energetic. We exchanged visits regularly. And then through these visits, we're able to plan conferences, papers, grant applications, and so on. He's now the vice president of the university dealing with international relations and still a good friend of the university. Since 2022, we started to have Turing scheme. So this replaced Erasmus. And this means that we were able to get to see some of the, I think, most active research labs in the world. This is Professor Pum Kamem. So you see him here, you see him here. So Professor Pum has a lab with 35 PhD students at all times, 10 postdocs. The place has events, I think 30 events every year, workshops, symposiums, where he is doing internationalization at home. He brings the leading experts in AI now. So he started with fixed point theory, convexity, and this is the training he provides. He selects the best students from Pakistan, from Ethiopia, from Nigeria, from all around the world. He brings them to this lab, and you'll see some of them visiting us. So we also had many guests at the university. We have the guests with Erasmus from Alba Iulia. Here we have Warren greeting Professor Tsuijie from Anhui University. And this was the first ever Key Action 107 application of the university. So this was Erasmus partnership outside Europe, 90,000 euros. It was great, but we could not start because of COVID. So the first visit was due to take place in June. Then we had Professor Subrata from Jadavpur. The first visit by Anand and Graham Orput. So this is the leaders from Vreta. They visited the university in 2018 for the first time. And then we had guests from Thailand. So this is Professor Tanakit, Professor Kasamsuk. with their PhD students. Now, and also Professor Poom with some collaborators. And then, actually, you've seen already some of my research before this session, because this picture was selected for the strategic framework document of the university. I'll tell you what these things are in the next slides. This was another visit by 5 PhD students, another visit by, and this is the first visitor we had from Thailand, who was actually Seifu Endre. He was from Ethiopia, finishing PhD in Kim Mongkut University in Bangkok. Now, what links the 2 PhD students, the 2 PhD research visitors, and the ones on this slide, is that these visits took place 2-3 years ago. Now they are already lecturers in their universities, and they have Darby in their CV. So Darby became part of their journey as well. Yes, and I love graduation ceremonies. And this is another unique experience we provide to our visiting students. I wanted to start with this, but I'd like to really thank the events team, marketing team. It's like whenever we go to these graduation ceremonies, and I think if you take it away something from today, so I'd really invite all staff to join these graduation ceremonies. I think they're fantastic. And it's a unique occasion to celebrate our students and also to realize the huge work behind the operation of a university. So I always enjoy to have a photo with this colleague from security, because I know that he's there and not in the university. And then this gentleman seemed very familiar at the last graduation ceremony. And actually, I realized that we met at a training course that we did, where we did maths training for the Bosnia-Herzegovina community. So this is partnership, a program lead for China. We have we started this program in 2022. We already have 3 cohorts of students with over 330 students. This is from a picture taken during our visit in October 2023. Now, I'm joined by a team of excellent academics, and I know that some students in this room are very interested about the Turing scheme applications. So this year we are going to have, for the first time, 4 Turing scheme placements in China. So we are going to take the students with us, and also 4 Turing scheme placements in Thailand. So I'll come back with information. On the 4th of February, we have the training. Finally, I talked about lots of things, but now let's go back to maths. So you relaxed enough. So Roger Bacon was saying that maths is the key and the door to the sciences. And Galileo Galilei was saying that this is the language of the universe. Now, maths has a significant emotional impact. So Martin Luther was saying that medicine makes people ill, mathematics makes them sad, and theology makes them sinful. And then a line I use in my open days, or like opening inaugural lectures with the course, is this one from Albert Einstein. He was saying that do not worry about your math problems, mine are far greater. So, and then my understanding is that if Einstein had problems with his maths, then it's okay for me also to struggle from time to time. And Sofia Kovalevskaya was saying that it is impossible to be a mathematician without being having the soul of a poet as well, because you'll see that some of the maths is poetry. Now, how big is mathematics? You encounter some maths up to O levels. So you get like geometry, algebra, some calculus, some statistics, right? Now, in university, you find out that there is functional analysis. Calculus is not just calculus, it's 1, 2, 3, 4, and so on. Differential geometry and applied mathematics. But if you check the mathematics subject classification, there are about 5,000 fields in mathematics. I remember that I was almost crushed when I entered the maths library in Cluj-Napoca. And then after I opened the door, I've seen like a shelf which was like 6 meters high, 6 meters tall, and then very long. And I thought, I'll never have time in my life to read maybe just this shelf. But yeah, maths is big. Right, we have many numbers in mathematics. Number 0 only appeared quite late, actually, in history. And I wanted to use the example of number pi. So this number pi, you divide the circumference of a circle by the diameter, And there are many approximations known since antiquity, but only in 1760s, Lambert proved that this number is irrational. So the digits do not repeat and they cannot be predicted. So we have these numbers, natural numbers. Then if you take with plus minus sign, you have whole numbers. Then if you take fractions, you have rational. Then here the last layer is real numbers. So this means including irrational. So this is pi, e, and so on. Now, if you don't like maths, you can also think of this pi. Yes. Yeah, so that's fine too. Yes. Now about infinity. So this concept of infinity bothered many minds, right? Because it's like if you have something that if you have 100 people in this room, so you count up to 100. How do we know that there are 100 people in this room? What would we do? We'll start to count, right? So we would say 1, 2, 3, 4, 5. So this means that, and then when we finish, this is the number of elements in this set. So what we actually do when we say the size of a finite set is we establish a one-to-one correspondence between the numbers, between the first element and the last element, right? Now, so according to Big Bang, there is, I'm not sure if you find infinity in the universe, because an estimation of the number of atoms is 10 to 80. In maths, you can put that to power 10, 100, and you get something bigger. But this infinity has many interesting properties. So if you take the numbers starting from 0, so 0, 1, 2, 3, 4, and then the number starting from 1, so apparently, you actually delete the first term, right? So which of the two sets has more elements? Right, so if you have 100 people in this room and you take one out, you have less elements. But with infinity is different, because if you take this process and you attach to every number in the first set a correspondent in the second set, if you can do this without leaving any number outside, then the two sets have the same number of elements, right? So even if you delete 1000 elements from an infinite set, you still have the same number of elements that you had at the start. Same thing applies with division. So if you take the numbers 1, 2, 3, 4, and then you only take the even numbers, they still remain the same. So if you take an infinite set, you divide it in two parts. Each of the parts has the same cardinal as the set at the start. And trying to understand infinity, there was a mathematician in the 19th century, Georg Cantor, who had the following idea. So when you think of the fractions between 0 and 1, you have 1/2, 1/3, 1/4. So you have infinitely many fractions. Between 2 and 3, infinitely many fractions. And Cantor had the idea, how many fractions are there? And then his genius idea was that he could arrange actually these fractions in a table. And then if you go through if you visit these fractions in this way, like a spiral, so you are going along these arrows, then you can establish a one-to-one correspondence between the fractions and the natural numbers. And this means that they have the same number of elements. So between 0 and 1, you have infinitely many numbers. Between 2 and 3, infinitely many. But still, the fractions are exactly the same number. Then also, Cantor had tried to count how many real numbers are there. And then, skipping the proof, but he proved that this is a totally different type of infinity. An infinity much bigger. So this is an uncountable infinity. So, and then he also developed the theory which shows that actually infinity is infinitely diverse. So my man was actually right with the infinity of infinites. Then another interesting concept that fascinates me is dimension. So a point, if you are at a point, you don't move in any direction. So you have dimension 0. If you have a line, you can move in one direction. So that's dimension 1. If you have a square, you can move in two directions. So that's dimension 2. Cube, dimension 3, and so on. But in maths, you can go on. So you can have 4 dimensions, but you can also have infinitely many dimensions. Then, an experiment done in 1960s by Mandelbrot tried to measure the length of the UK coastline. And then when he used rods of 200 kilometers, he was getting 2,350 kilometers. But when he used rods of 100 kilometers, the length was bigger. When he had roads of 50 kilometers, this was increasing even further. And he reached to the idea of fractal. So I'll just go very quickly through this concept using the example of the Sierpinski triangle. So you start with the full triangle, you take the midpoints of the sides. This divides the initial triangle into 4 equal triangles. And then you extract the one in the middle. So you get 3 out of the 4 full triangles. But you also draw 3 new lines, 3 new sides. You can quickly check that the area of the new object is 3/4 of the original, but the perimeter is 3/2 of the times the original. If you keep iterating, so if you apply this process over and over again, what you get is that you create an object. So through this mathematical iteration, you create an object which has infinite perimeter and 0 area. So what is the dimension? Infinite perimeter means the dimension is greater than 1. 0 area, dimension less than 2. So mathematicians had to come up with a theory to explain what is going on. And this was the Hausdorff dimension, one of the dimension concepts, which estimates that this dimension is 1.58. Now, this type of object is very used in computer graphics, because this means that you can give the impression of some field spaces using little amount of information. Then Fibonacci numbers, we could not have like a generic maths presentation without the Fibonacci numbers. So these are the numbers 0, 1, 1, 2, 3, 4. The rule is that you add 2 numbers to get the next. You start from 0 and 1. These numbers were published in Liber Abaci by Leonardo Pisano, also called Fibonacci. But these numbers appear in nature, they appear in music, they appear in many patterns. For example, if you want to find the optimal shape of a concentrated solar power plant, this was the shape which is linked to the Fermat spiral, which is based on Fibonacci. Now, there is research showing that these Fibonacci numbers were found in India around 400 BC. So maybe these are not Fibonacci numbers. So if you are interested in the decolonization of mathematics, I think this is a powerful example. So like Pythagoras theorem, like all these things that we attach to someone, maybe they were just more popular, but maybe it's not their concept. And now this is the power of mathematics. So yes, you can compute these numbers, first, second, and so on, but the power of mathematics is that it can give you a formula with which you can generate any of those numbers. Also, infinite sums. So if you have like the sequences were so the sequence was the list of numbers, never ending, but you can also have infinite sums. And what's interesting is that these infinite sums, you can have infinite sum of positive numbers, which has finite sum. And this is like the more mathematics you know, the more jokes you can understand. This is calculus joke. So it's like infinitely many mathematicians walk into a bar. The first one says, I'll have a beer. The second one says, I'll have half of a beer. The next one says, I'll have a quarter of a beer. So every time you get a half of what the previous one had. And then the barman pulls the 2 beers on the table. And the mathematician says, so are you joking? Is this correct? And the bartender says, come on, guys, know your limits. So the joke is that if you add a half, so if you use this unit square, you have a half, a quarter, an eighth, a 16th, and then when you add all these numbers, you get 1. So that's the proof without words. Then complex numbers. So these are important for the following slides. So we have the real numbers, but in real numbers, you cannot solve some equations. If you take the quadratic x squared plus 1 and you plot the graph only for real numbers, this curve will always sit above the horizontal axis. So you don't have a solution. But mathematicians needed to solve this equation. So they said, okay, we take x squared, we take 1 on the other side, x squared equals -1. We take the square root, and we denote this. This is I. This is the imaginary number. And then these numbers are numbers in 2 dimensions. So they have real part horizontally and the imaginary part vertically. This leads also to the most beautiful formula in mathematics. So Rich and Feynman and others said that this is the most beautiful. It helps us understand more jokes. So life is complex because it has real and imaginary components. And also pi, conversation between pi and I, get real, be rational, and also materials for open days, because marketing was not very fond of this, but maths applicants were very excited about it. And also Thai visitors, I brought them to the open day, and then Professor Tanakit was saying, make it complex, professor, make it complex. Yeah, so we crossed this because complex numbers are the next level. And then there is a famous word by Paul Erdős that a mathematician is a machine turning coffee into theorems. And this is exactly what happened with me at Derby. So in my second week as a Derby academic, I had a coffee with Professor Peter Larcombe, who showed me some sequences. These were sequences like Fibonacci numbers, but in 2 dimensions. And he showed me that sometimes this, so you have patterns with 12 terms only, and these patterns were self-repeating. And he asked me, can you find the proof? So when does this property happen? And then I was able to find the proof, to do many simulations. He was actually reigniting some research left open by A.F. Horodam, started in 1960s. Then we were able to characterize the periodic sequences. That was the first paper in Fibonacci Quarterly. That was a 50 years old journal. Then we were able to enumerate these patterns using combinatorics, and that was another paper. And what do you do with your research? Then you start to show it around the world. And we started with the British Combinatorial Colloquium. After my presentation, I had an invitation to give an invited lecture to Open University. So we did that. And then I presented at the interdisciplinary forum of Babeș-Bolyai University my presentation on the mathematics of beauty. The other presenter was a psychologist who is now the Minister of Education in Romania. Then we started to advance this research more. We started to look at non-periodic sequences as well. We were able to design a new random number generator. And this was the basis for my second PhD in Cluj-Napoca, where Professor Tom Ward was my external examiner. And actually, he was the author of the main textbook in recurrent sequences in 2003. I think this quote is very relevant for this presentation, because Dijkstra was saying that a picture may be worth 1,000 words, but a formula is worth 1,000 pictures, because all these formulas are obtained from, all these pictures are generated by a single formula with changing some parameters. And then next year we made it to the top, because we submitted this research to the International Congress of Mathematicians. This was the forum where the Fields medals, like the Nobel Prize for Mathematics, is awarded. And we had 5,500 mathematicians from all around the world, about 90 from UK, and 1 was from Derby. So after I made it here, I was getting angry whenever I was hearing from colleagues, we are not very good with research because we are Derby. I said, what do you mean? I mean, I presented Derby research at this forum. So I was able to present the research. I was able to meet a professor, Kim Donghua, who was writing emotions into equations, working with Kia. And they were telling that actually Korean cars were so successful because they had mathematical models for modeling the client expectations, right? Embedding those in their car designs was making the cars sell. And then here I also met, here we were dressed in Prime Minister and Korean King with Professor Raja from India. And then this became one of my leading collaborators. Now, starting from conversations with my colleague Stuart Berry. So Stuart was at the university for 40 years. He was not publishing much, but if you had any problem, he was able to build a heuristic, a code in 12 pages, 15 pages, and so on that worked. And he was able to solve where to place speakers in a concert venue. Using some simulated annealing, taboo search, he was able to do that. Scheduling for timetables, trains, and so on, he was able to do that. And then he showed us a problem about traffic assignment. So you have a number of routes between an origin and the destination, and you want to push 1,000 cars. You have a certain cost of sending the cars along each of the different options, and you have to find the social optimum, which is the minimum travel cost overall, but normally drivers choose what's best for them. And this means that you have traffic jams. So this is equilibrium solution. And then for this problem, we started to explore different versions of the equilibrium problems, different versions of optimal problems. And we had the first, and you have like the price of anarchy and so on. So this is a very important concept. But in 2017, this colleague invited me to India. The conference was during teaching time. I never left Derby during teaching time before that. And I asked this was my first invitation as a keynote speaker. I asked my manager, he agreed. I don't know how, but I was very happy. And then I was able to give a keynote presentation. But I spoke to our international team. They asked me, have you seen any students? I said, yes, I've seen 450 students. It was a great experience. And I was also invited to inaugurate a research center for mathematics. And that was like off the schedule. But then last summer, they called me and they said, you remember when you came to this inauguration? Now we have 12 PhD students from that center. Then this collaboration led to ref papers, visits by another collaborator, Professor Popovic. Yeah, I will skip these maths. You can close your eyes. I'll tell you when it's not maths anymore. But I started to do research with Professor Nicolae Popovic on generalized convexity, and this led to invitations to present at the biggest operations research forum in the United States. So this was 6,000 participants. Then I started to work with Professor Andrica on partitions, with partitions of multisets with equal sums. This paper is important because, for example, if you want to send packages, data packages along multiple channels, if you want to have perfect balance, how many configurations are possible? And then only in November, we found out that there is a paper citing us. Actually, we built the theory for this. There was only theory for sending all this data along two channels. But we did the theory from scratch for K channels. And then they applied this problem to construct and enumerate all the balanced rotation symmetric Boolean functions, closing the no-con problem in cryptography, which was open for 20 years. So that was one thing. The cyclotomic polynomials, you have nice formulae about the poetry, but also very nice marketing materials. So if you've seen these photos already, then dynamic geometry. So we did a fair bit of maths, and this dynamic geometry took us far away. We had an invitation from ICDEA. This was a conference organized in Paris by Professor Sorino Laru, and we had an invitation to organize a special session. And I presented our research. It was well received. The session was successful, but I had this photo, and I've seen that there was a gentleman approaching me. I was showing off my I love maths badge. And then during this photo, this person said, I'm the new president of the IMA. We make these badges. I'm the boss here. So this was Professor Paul Glendinning. Then I'll just go very quickly through some applied research. So placement visits. This can be very tiring for staff, so you have to travel long distance and so on. But I was fortunate to visit Luke, and Luke was the assistant of the operations manager of a huge warehouse. Then with him, we discussed about how to optimize the operations because they have 1,000 pickers. So you could plan better the routing across all that warehouse. That was as big as 7 football pitches. And then I followed his career. And he's now DHL's fleet controller for DHL. So he applied the skills developed here. Then another item of applied research is ceramic color models. This was a project where we were helping a company improve the process of designing new ceramic colors. So they had to identify which pigments and which concentrations. And we won grants. We improved the process, but the heroes of this project for me were our Derby students. And then through URSS, through Erasmus, they were able to contribute, and now they're both doing PhD. Another highlight for this session is Craig. I'm very happy that Craig is here. So Craig was doing, so he was a Derby graduate, but many years before. I had a presentation in his school. He was a math teacher at Bilborough College, at Nottingham College. Yes, and then I told him, look, we are launching a new MSc in computational mathematics. He was the only student that year, but he was a brilliant student. Then he did PhD, and then he worked in London on very good money, I know. But now he's a research fellow in machine learning. Yes, and then also his PhD was on the ALICE CERN project, and it's the only PhD I know about in my experience where there were no corrections. So I think that's quite impressive. Then we had many successful. So I tried to reduce the number of slides. So we had many successful. So I tried to really put everything. So we had Claire Barrett. I'll just use a few seconds for each slide. So Claire Barrett was doing placement with IBM. Then she's now senior solutions architect. This project with our Derby students came in the top 10 in the world in the IBM Global Challenge. And this project was led by my colleague, Rich Collins. So he was the advisor for these 3 students. And I think they did an amazing job. But then they came back to Derby for when we had the first enhancement week. She was one of the speakers for our students. Then we did research on mafia networks. We got our hands on data from Sicilian mafia, investigations of the European police. And then we were able to reconstruct the networks of the meetings and the phone calls between mafia members. And then we were able to build mathematical models to tell law enforcement agencies which are the most dangerous criminals, not only in terms of connections, but also in terms of influence. So we had many researchers in the team. Lucia Caballaro led the project. And then she did postdoc, and now she's a very successful lecturer. And then we presented this research. So it was all over the European press, and also I presented in Ethiopia when I was invited by London Mathematical. I had funding from London Mathematical Society to do some workshops. Then Encyclopedia of Integer Sequences. So we don't only have Fibonacci, we have almost 400,000 sequences. And I just want to tell you that some Derby students have their own sequences as well. So I think that's very exciting. And then we also had a maths conference at the university. We had Professor Tom Ward, Professor Preda Mihailescu, Professor Martin Bochner, and Professor Vadim Lozing. And then how do you involve your students with research? So my message from these slides is that there is research of different levels. So there is research, pedagogic research, there is technical research. So we had many students who got involved with this symposium on mathematical education in the European context. And then they did very well in their careers. This is a Derby student. This was the first Derby student to go abroad with Erasmus. And then she won the URSS award. She gave the vote of thanks, but then she's now working for the Met Office. And then we also do the research in AI for education, research on the impact of numeracy training courses on our students. And this was the research conference in Portugal. So here we have David, Max, and Daman also. And this is Socrates, and he's the lead of the AI in Education Research Group. And I can tell you that one of the biggest assets of this university are the mature students. So we had David. He developed a Derby GPT, like a version to help the students. And this was the feedback provided by the GPT itself. And it was saying that, look, you can get advice on how to survive Ovidiu's maths jokes. This is where you can ask for help. Then we did many activities with Black History Month. So we had students to promote, and that was the president of the IMA. So he solicited that. Then we had other research conferences where our students built a new board game in a suitcase. And this was very well received by the participants at the conference. And this was a paper published in Open Education Studies. Then we are working closely with the Romanian community as well. So I had an award for supporting the community throughout the COVID pandemic. We have a society within the Nottinghamshire Police. This is Father Dan, who is running around the whole area. And this is one of the, I think, excellent Derby graduates. He's a graduate from law, but he's a member of our community. And he is now District Crown Prosecutor. He was the top law student in his year. He graduated in 2018, and now he's already district crown prosecutor in the magistrate's court. This is the applied mathematics I had to solve this month normally. So in our parish, we had 300 locations. We had to visit across 12 cities. Father Dan is the main project lead for this. So he has to visit. This is the map for Derby. And this is an application of the vehicle routing problem. So we have to solve this. Yes, and I will now just speak very quickly about math support. So I think it's critical to get math support right. This improves university KPIs overall. And we had, again, mature students. I want to highlight here, this is Natalie Bailey. So she was a senior fellow in Cambridge. And for family reasons, she decided to study maths at Derby. And she was the engine between setting up a channel for the Math Society. We interviewed the president of the IMA. We still post many videos to help the students learn mathematics. And then when I started to prepare the TEF submission for maths, I realized that actually we had in terms of math support, I was not starting actually thinking myself. We had a history of 30 years of doing that very well. And through interactions with Professor Graham Workwood, I came across this numeracy gap problem. So there is a big issue in our society. My focus was maths anxiety. I was thinking that the fear of maths is the problem, but he told me, no, I don't think that this is the biggest problem. The bigger problem is that about 16% of students do A-levels for maths, but nothing is done for the others. And I think we need to fill this numeracy gap. And I think at Derby, in collaboration with Reta, we were able to build a solid partnership to develop a solution for filling the numeracy gap. We helped them transform their technology with topics, with dashboards, with the new courses developed in collaboration with colleagues from across the university. This made lots of students revise and get to terms with their maths. It had profound impact in my classroom. So it helped students get their pass rate. So the pass rate in my module went up from 85% to 90%. That's a huge improvement. But in terms of good grades, this went from 60% to 70%. We had digital badges. We have now pedagogic research with the data from these modules are running in Greece and China as well. We started to train the communities as well. We had Romania community, Bosnia-Herzegovina, Sadaka community. This was a program sponsored by the European Social Fund, and this won us the award for the best summative assessment project. So I think I'll stop here. Thank you.